8.4, using systems of equations. So we're going to use the systems to solve problems that we're given. Again, we're going to use that same plan, the understand the problem, develop and carry out a plan, and then answer and check your answer. So solve the answer and then check our answer. Alright. So let's look at the first one. And it is a basketball team plays 162 games. They won 44 more games than they lost. How many games did they lose? So my first step is to create a let statement. So let x equal the number of games won and y equal number of games lost. So a basketball, this is baseball, a baseball team, I don't know why I said basketball, played 162 games. So that means that it would be x plus y is equal to 162. And then I also know they won 44 more games than they lost. So x, number of games won, minus number of games lost is equal to 44. Or I could have written that second statement as they won, so x is equal to y plus 44. So I'm just turning that into that because now I have a positive x, or positive y and a negative y, and I can make a big addition problem. Notice that my y's now can cancel. 2x is equal to 206. And so x equals 103. But x means the number of games they won, and I want to know how many games did they lose. So now I need to go x minus, I'm actually going to plug it in, 103 minus y, and we'll do plus y, is equal to 162. So y is equal to 162 minus 103. That's going to be 59. So they lost 59 games. Okay, let's try another one. Ramon sells cars and trucks. He has room on his lot for 510 vehicles. So he sells cars and trucks, 510 vehicles. From experience, he knows that his profits will be greatest if he has 190 more cars than trucks. How many of each vehicle should he have? So let's start by that let statement. Let x equal cars, or number of cars, and y will equal the number of trucks. So my first equation is I know he has room for 510 vehicles. So x plus y will equal 510. In my second equation, I know that from experience he knows his profits will be greatest if he has 190 more cars than trucks. So cars should equal trucks plus 190. Now I could use either substitution or elimination. Let's in this case use substitution. So I'm going to take this piece right here and substitute it in for x. So I end up with y plus 190 plus y is equal to 510. 2y plus 190 is equal to 510. 2y is equal to 320. Y is equal to 160. So y is how many trucks he should have. So he should have 160 trucks, but I need to know how many cars he should have. So I'm going to plug that into equation 2. X is equal to 160 plus 190. So X is equal to 350. Okay, another example. Kayla is 21 years older than Laura. In 6 years, Kayla will be twice as old as Laura. How old are they now? Okay. So I want to write two equations. I know that Kayla's age is 20, so I need my let statement. Let X equal Kayla's age and Y equal Laura's age. So X equals 21 plus Y. And then my other piece of information that I know is in 6 years, Kayla will be twice as old as Laura. So X plus 6 will equal Y plus 6 times 2. So both of them 6 years, and that means that Kayla's age will be twice as old as Laura's. Alright, so now let's do a little math to solve this out. And my first equation, I'm going to leave it as is, so X equals 21 plus Y. My second equation, I want to do some multiplication. So X plus 6 is equal to 2Y plus 12. I'm going to minus 6 from both sides. I have X is equal to 2Y minus 6 plus 6. So now I know what X is equal to. I'm going to plug it in for this X right here. And I'll get 2Y plus 6 is equal to 21 plus Y. Subtract Y, and minus 6. Y is equal to 21 minus 6, which is 15. So Laura's age is equal to 15. Now we need to get the next age. So X is equal to 21 plus 15. X is equal to 36. So Kayla's age is equal to 36. So really, this is all working on creating those equations. Here's another example of creating an equation. Rent-A-Truck. Rent-A-Truck rents small trucks at a daily rate of $35.95 plus 30 cents per mile. So this one's Rent-A-Truck, $35.95 plus 90 cents a mile. Budget Rentals rents the same size truck at a daily rate of $32.95 plus 32 cents per mile. For what mileage are they costing the same? First and foremost, let's do our let statement. So I'm going to say let, or actually in this case, instead of writing a let statement, I want to write two different equations. I want Rent-A-Truck equation and I want the budget rental equation. And our rent-a-truck equation is going to be the profit, or the cost, we'll call it C of X, will equal 33.95 plus 0.30x, because that's an extra 30 cents per mile. In the budget rental truck, the cost will equal 32.95 plus 0.32x. And what we're really looking at here is, when are these two exactly the same? Well, I have them both set equal to C of X, which could also mean Y, so I could plug them equal to each other and do 33.95 plus 0.30x is equal to 32.95 plus 0.32x. And subtract 32.95 and minus 0.30x. I end up with 1 is equal to 0.02x. Divide by 0.02. 0.02. End up with x is equal to 50. So at 50 miles, they're going to cost the same. And if I plug this all back in, and I'm going to take that 50 and plug it back up into either equation, I find out that they'll cost the same at $48.95. Alright, so we're going to practice more of these in class. I know that was a lot.